In section 4.3, we got modern atomic theory. And have you ever wondered what produces the colors in a fireworks display? Certain compounds will produce certain colors of light when they are heated. Compounds containing the element strontium produce red light. Barium compounds, green light. The different colors come from different compounds. And this Bohr's model and some of the other things we're going to look at in this section explain why that happens. So, what can happen to electrons when atoms gain or lose energy? A key question. So, Bohr's atomic model, like Rutherford's, had a nucleus surrounded by a large volume of space. Bohr's model focused on the electrons in their arrangement. Rutherford focused more on the nucleus. Bohr's model, the electrons move with constant speed in fixed orbits around the nucleus, much like planets around the sun. Sometimes it's called the planetary model. And each electron has a specific amount of energy. And when atoms gain or lose energy, the energy of the electron can change. And the electrons are assigned to things we call energy levels, the possible energies an electron can have. And an electron exists only in a certain energy level. It can't exist in between them. And each energy level is associated with an orbit. The farther away you move from the nucleus, the higher energy they are. And electrons in an atom can move from one energy to another as the atom gains or loses energy. One analogy can be used for this is a staircase. Lowest level, starting at the bottom of the staircase, each step up, higher energy level, and the step height represents an energy difference between levels. And you can only move in whole numbers of stairs. You can't stand on 1.5, step number 1.5. There is none. You're on step 1 or you're on step 2. And it might move up or down 2 or more energy level if it gains just the right amount of energy. We end up calling that type of energy a quantum. We study this a lot when we take chemistry. Size of the jump between energy levels determines the amount of energy gained or lost, and no two elements have the same set of energy levels. The scientists measure the amount of energy gained when an electron absorbs energy and moves to a higher energy level, or measures the energy released when it moves to a lower energy. And light is a form of energy that can be observed. So we can see the light emitted. And that's what makes the colors in fireworks. So, movement of electrons explains what you see when fireworks explode. Heat causes the electrons to move to higher energy levels, so when those electrons move back to the lower energy levels, they release energy, and that can be released as visible light. And different elements release different colors of light. Because no two elements have the same set of energy levels. So, Bohr's model only was around for a while. We still hold on to things from it, like the energy levels. But it's been replaced now with the electron cloud model. So an electron cloud is a visual model of the most likely locations for electrons in an atom. And we use the electron cloud model to describe the possible locations of electrons around the nucleus. So Bohr's model improved as we had further discoveries. Bohr correctly assigned energy levels, but electrons do not move like planets in a solar system. So today we use probability when trying to predict the locations and motions of electrons in atoms. Electron cloud is a visual model of the most likely locations for electrons in an atom. So the electron cloud model replaced Bohr's vision of electrons moving in predictable paths. So this is what our model of an atom would look like today. We got the nucleus and we got the electron cloud. The fan windmill here is a good analogy for an electron cloud. When you see it moving here, you know there's blades in there, but you don't know exactly where they are at any particular time. When it's at rest, you can count the number of blades, but when they're moving, you see a blur. You know the blades are located somewhere in there, but at any specific moment, you can't be exactly sure where the blades are. And then we break the electron cloud down into orbitals. And this is a region of space around the nucleus where an electron is likely to be found. So the electron cloud is made up of orbitals. An electron cloud, good approximation of how electrons behave in their orbitals. And there's a little analogy that would kind of represent an orbital. If you mark your exact location with a dot once every 10 minutes over a period of 1 week, the dots on the map are a model of your orbital. They describe your most likely location. Places you visit most often would have the most dots. Places you visit the least would have the least dots. So the least energy, our first energy level, has only one orbital, and higher energies levels have more than one orbital. So energy level 1, 1 orbital, 2 electrons. Energy level 2, 4 orbitals, 8 electrons. Energy level 3, 9 orbitals, 18 electrons. And energy level 4, 16 orbitals, 32 electrons. And you might notice that this thing is, if we call this one n, this one's n squared, and this one is 2n squared. 1 squared is doubling this one, we're squaring that one. And the most stable electron, we talk about electron configurations, the arrangements of the orbitals in an atom. And the most lowest possible energy, or the most stable, is considered ground state. In chemistry, we do a lot of work with developing ground state electron configurations. So the most stable electron configurations, lowest possible energies, or ground state. So lithium atom has 3 electrons. 2 of those in ground state are in the first energy level, and then the third one has to be in the second energy level. If one of those first 2 electrons moves up to higher energy level, then we call this an excited state. That electron, if it gets moved up, eventually will return to ground state, and that's when, like on fireworks, we'd see the release of colors. Ground state could be like a gymnast here when they're on the floor, very stable. Standing on the bar here, not nearly as stable. That would be the excited state. And questions? According to Bohr's model of atom, which of the following can happen when an atom gains energy? We'll just jump ahead to the answer here. D. Electron can move to a higher energy level. Protons are not in energy levels. Neutrons won't be changed into protons during this process. And it returns to its ground state when it's moving to a lower energy level. That's why the other ones are wrong. How does the modern atomic theory describe the location of electrons in atoms? And C, B, answer. Electrons can be described as a cloud based on probable locations. And looking at some of the other ones, we haven't talked about Biro, modern or electron cloud model. Doesn't use planets, that was Bohr's model. And electrons move randomly in space about the nucleus. Somewhat true, but it's not completely random. We can predict their location. If it were random, we couldn't predict. In its ground state we see is the lowest possible energies. Be true, or not true, but doesn't have to be true, but protons can equal number of neutrons, but it has nothing to do with this process. There's no net charge on an atom, always true, but not talking about ground state, and ground state doesn't talk about isotopes. So that's our section 4.3. That's it for now.